All right. So topics today are going to be diagramming and debugging. And we talked a bit about debugging in class and the video that's posted online. I'm going to show you some more examples of that, and then I'm going to talk about debugging. Okay. But first, the midterm quiz. So the midterm quiz is going to be next Thursday. It is kind of a low-key deal. As long as you've been keeping up with the class, you should not have to cram for this. You might want to review your notes, go back through the lectures, that sort of thing. But it's mostly because you guys have been working in groups the whole time, and I need to test and see what your individual knowledge is. All right. So if you've been coasting, if your partner's been doing all the work this whole time, this is our reckoning. Okay. It's time to learn this stuff. I don't think anyone's in that boat, but anyway, I do want to evaluate the class, and I want to see like what we understand, and it's a chance for you at midterm to review the big ideas. We've been really getting into like the minutia of this project and how it works, but I want to think about some of the big ideas I talked about, earlier in the class about what parametric design entails. These ideas like setting up relationships between things using variables, right? Distribution logic. So basically the main topics from the last like 5 weeks, okay? Again, if you've been keeping up with it, you shouldn't need to cram. This should not be a stressful moment for you, all right? Next Thursday, it's in lab. It's going to be multiple choice. It's going to be a short answer. So it's not like, I do not require you to write an essay. I do not require you to like write code in class. You do not have to, I don't know, like write a play or something. It's very straightforward. It's mostly on vocabulary, concepts, and some short code IDs. So I will put up a little piece of code, and I might ask you like what it does. All right. I might put up a piece of code, and I might ask you like what's wrong with it. Okay. You will be able to use your notes and Grasshopper in lab. Like that's stupid for me to not let you use that because you'll have it most of the time, right? Like when you're trying to do this stuff. All right. That being said, do not count on your ability to fire up and write a Grasshopper program for every one of these questions. Like you're going to have to recall some of this stuff from memory, all right, unless you're very fast. Okay, I would say that if you could do that, you probably understand it well enough anyway. All right. Again, this is just a barometer on it. I'm not trying to trick anybody with this stuff. It is individual. I think it's been pretty clear. Don't cheat on this. I don't even know why you would really need to. The point of this is to learn it. Don't IM each other during class, like what the answers are. Don't tell people in the next lab like what's on the quiz, because I have 4 different algorithmically randomized versions of the quiz, and you will mess people up. All right. I don't think I'm going to need to worry about this, but just in case you were thinking about it, don't do it. All right. The topics are just basically the weekly topics, going all the way back to the first week, talking about variables and relationships. This is kind of like our column assignment, right? Creating dependencies between things, proportional relationships. Positioning, which is just how do you get something next to something or on top of something, or in a series to a line. A lot of you guys did this for your project. You should pretty much understand it at this point. Okay? What are various methods for positioning something, right? Which kind of gets into distribution. So like we can give something a point. We can give something a plane. There are lots of different ways to get points out of things. Okay, what are those? That heads us into sort of this thing with like the different kinds of 3D like topology. So how do you get points? How do you get points from curves? How do you get points from a surface? How do you get curves from a surface? How do you turn curves into a surface? All right. It would be helpful to like have an understanding of those basic techniques. I might ask you to name 1 or 2 of them. You'll have access to Grasshopper, so if you don't know the specific name of it, like there you go. But you should have an idea about what it is and what it looks like, okay? And how to transform like one into another. This is our bread and butter, all right? So, topological stuff I think is really important to understand. And then lastly, just have a knowledge of common bugs. And since you're here today, you are going to get some of this up front today. I'm going to talk about some of these things. But basically, I think there are problems that we've all encountered at some time. I might flash, I might have an image that you guys will look at, and you might identify like what the problem with it is. Or I might give you a script that has like a graphical problem, and you'd identify what that problem is. Why is the script like misbehaving? Okay, it's probably something you've seen before. Okay, you need to tell me what that problem is. So pretty straightforward. I don't expect it's going to take you the full like lab time again. If you have questions about it, if it's stressful for you, let me know. I think you guys have partners. You guys might want to study together. You might want to get together in a group. I don't think it really requires a lot though. But if you feel like you need it, that's something that might be helpful. Okay. So we have any questions about this?
How many questions?
I don't know. I haven't written it yet. I don't know. 14. More than 10, less than a lot. Okay. I need to make sure that, okay. So then we go on to the question for today, which is debugging, all right? So debugging is the most common activity in programming, aside from actually implementing the program or actually trying to like make the program in the first place. In fact, most of writing a program is debugging the program that you wrote. Okay? Programs are complicated, they have a lot of interacting variables, they're very hard to visualize, and you make errors all the time. Like professional programmers make tons of errors. Expert programmers even, okay? What's a bug? Bug is an error in a program that causes it to crash or otherwise unexpected behavior. So if a program stops working for some reason, right, that's a bug. That's a very obvious bug. But more sinister bugs are when the program doesn't quite do like what you want it to, or even more sinister, it doesn't do anything. Like nothing happens. Like you've done something and nothing changes. Because that is pretty scary, okay? Debugging, if I have to get pedantic, right, is the practice of finding and resolving bugs in software. You're like removing bugs. It involves a bit of like sleuthing. You have to kind of investigate, a little bit of like detective work, and problem solving, okay? It's not an easy activity. It's not easy for programmers, but it's one of these things that like we have to learn, and that's what the purpose of this lecture is. This is actually the first time I've given this particular lecture, because I want to teach you explicitly some of the methods for resolving bugs, okay? Some of it might seem like common sense, but I think articulating that stuff is really useful, okay? So you can keep a little list with you as you're writing your programs of like things you can try as you're like working on it to kind of solve these things. Some of you guys have already like done some of these things before, but we haven't like talked about it yet. Okay? These are good programming practices. So why is studying debugging important? Because about 50 to 75% of programming is debugging. And this has actually been scientifically, well, empirically proven. Experts, about half of their time is actually debugging. Novices, which are you guys, it's about 75, and that's pretty generous. More like 90% of programming is debugging, all right? And that's okay. But even when you're an expert, half of your time is still debugging. So the better you get at it, the less time you'll spend having to write programs, the more time you'll spend getting outside in the sun and like doing other like fun things. All right? I think programming is fun though. So if we can minimize that that amount of work, we really got something. What I'm going to talk about today are three like major topics. So avoiding making bugs, specific techniques for locating and solving bugs. Well, they're kind of general, I guess. They're not like specific to a particular program. But then lastly, we're going to look at some bugs and some bug patterns. Okay, so what are some things that you guys have maybe seen? Let's like sort of talk about those and talk about how we learn from bugs. Okay. The best way to limit debugging is to avoid making bugs in the first place, right? Don't make an error. Then you don't have to find it. Okay. We've talked about some of these ideas before. Good design prevents bugs. So when you're writing a program, if you know what you're going to do ahead of time, you have a sense of the structure of the program, you've diagrammed it, right? I told you guys you need to make a sketch or something like that. You can avoid it because you know what's supposed to happen in each stage, what needs to happen before something else needs to happen. You're not just writing it for the first time in the computer, okay? That might be bound to cause you some problems, okay? So if you know what you're going to do and how, you have a plan, that's the first step, okay? A well-designed program, like a well-architected program, removes a lion's share of bugs, okay? If you just go in willy-nilly, you might cause yourself some problems. We talked about this also. A big part of it is actually giving yourself enough time. Again, if you try to do things quickly, you're more apt to make mistakes. If you give yourself time, usually by not starting at the last minute, you will avoid problems. It'll actually take you longer if you try to do it in a short amount of time. You're going to end up like basically screwing yourself. Okay. When you're writing a program, you want to check each piece of the program as you go to make sure it works before you keep adding stuff. Like you don't write like the whole program at once and then see if it works. Like you get one little piece to work, right? Even like a minor thing, like even making sure, you know, like you put in a circle and you can control the radius. Okay, does that work? Okay, then I can do something else to it. Does that piece work? Okay. Like when I'm writing programs on the screen, when I'm showing you, like I'm kind of flying through these things, but like when you do it, especially now because you're still kind of fresh with this, you really want to stop and slow down and make sure that each piece works, because then you can catch a bug before it gets buried like deep in the program. Okay? If something was working and you added something and now it's not working, then you're pretty much sure that you just caused it. Okay? If you didn't try the program out until like further on down the line, you have no idea where it happened, okay? Like where that accident occurred. So really slowing down is really good advice. I know it's hard because you guys have deadlines and you have other things to focus on, but it's the best advice I can give you is just to approach it in a very zen, slow kind of way, okay? I told you this, and I don't practice this very well in class because it does take a little bit of time, but keeping your scripts organized and your variables labeled is really important. The hardest thing sometimes, right, is actually finding where that one component is that you need to plug something into or pull something out of, and it's like buried in this mass of, you know, cables. It's like pulling your Christmas lights out, you know, and there's all these like things, and you can't get the strings untangled. Like you can't find the socket. That's exactly what ends up happening in our scripts. If you slow down and you kind of organize things as you go, then that can kind of prevent that from happening. And also it makes you faster because the amount of time you spend organizing it is less time you spend hunting for those components, okay? If you line up the components that you know that you're going to need in the same kind of column or in the same area, that's also helpful, right? If you need a list of points, put those points together at that stage, right? If you're going to transform something or there's a really important component, leave it in the middle of some white space for a while until you can sort it out. But if you kind of do things willy-nilly, the cables get turned around like backwards, they get kind of confused, okay? So that's a really helpful thing to do as well. Use panels to explain parts of your script. I didn't really talk about this, but I think you've seen some examples of this. You can open a panel up and you can type in it, and you can leave it in your script as like a note to yourself, like a little post-it note, and you can say like, okay, this part of the script is supposed to do this, or like, in this part of the script, like, this is the process I'm using. And this is really useful because if you stop working on a program and you have to come back to it, sometimes you forget like what you were doing. Or if your partner opens up a program and they don't understand like what you're trying to do, or maybe they think they understand what you're trying to do and they end up breaking it. If you leave them a little note inside the program, like it's a really useful thing. In real code, we write a lot of, pretty much every couple lines has like a comment. You're explaining what a section does or what a line does. That's because you never know who's going to pick up your program later on and need to modify it. If you pick up your program later on, I guarantee you, like even in a couple of weeks, you might even forget like how it works. So leaving little notes for yourself is a really easy way to limit the amount of bugs that you introduce in the program, or to help you solve a bug, right? If you know what the error is, like if you say there's a problem with this piece of it, then you're more likely to come back and be able to solve it later. I know you guys can't always work on these things in a long session, but so you need those little signposts for yourself, okay? So panels are really useful for that, just to leave comments. So now we get into talking a little bit about finding and fixing bugs. So inevitably, you're still going to have like bugs in your program. Okay, even if you do the best you can while you're programming it, before you program it, you're going to end up with bugs. So like I said, some of them will crash the script and cause an error. And those are pretty good because you'll get a nice little error message sometimes, and usually it'll diagnose it. It'll say like this thing doesn't have the right inputs or something, or that this thing's not getting data. Then you can begin to trace it. Others like won't, and then that becomes a little bit more difficult. So I'm going to talk about both problems right now. Okay. If a script is broken, you want to work backwards from the message. So the nice thing about Grasshopper is everything's like linked together. So if you have a red box or an orange box like somewhere, and that's the last thing, you can look at the error message of that, see what that problem is. Again, maybe it's a mismatched data type, or it's the wrong like format or something like that, and then you trace that thing backwards. Okay, what's plugged into it? Okay, what's that thing sending to it, right? Is that the right data? Is there nothing there? Then you need to go back further, right? So look at the things in order, tracing them backwards from the stack. And again, I think you guys have probably done this before, but I want to tell you, the procedure explicitly here. Check to make sure you satisfy the inputs. So one way to do it is to mouse over. Another way to do it is to add in like a panel. Okay, that way you can see it so you can see multiple things at once. Maybe your program. This is one of the sinister things about programming. When we have variables in a program, when we can vary things, with a certain range of variables, your program might work, right? And when you hit a certain other range, like it might not work, okay? One of the things we've seen that happen with is like with culls, or things where we need like an odd amount or like an even amount of numbers. The program will work with an odd number, but it won't work with an even number. And so like you think your script will work, and then all of a sudden later on you feed it an odd value, or something way back in your script makes an odd value, and all of a sudden your script like breaks. Okay? That's where visualizing this stuff really helps, because you may have convinced yourself by mousing over that it's fine. Okay? But then suddenly something else happens and the whole program like breaks. Okay? So having those little panel components out while you're trying to work is really useful. It's one of the nice things about Grasshopper as a language. In other programming languages, you have to run the program and then you just get a bunch of output like a form, and you have to look at it and find out when it happened. In Grasshopper, you get a real-time like feedback on what's happening in the program. Okay, so it's a nice little visual aid. Like I said before, one of the first things you want to do is look at the newest code that you made. That's almost possible. It's almost always the place where the error happened, because it's the last thing you did. And if you're going slowly, right, you can trace that. What's helpful to do then is to take it out and try putting it back in, or try rebuilding the last piece of your script. Find out like why that caused a problem. Okay. Like, you want to sort of, it's like you're fixing a car or any kind of appliance or like whatever. You want to reproduce the error that happened, okay? And sometimes also, I hate to say this, but like Grasshopper is a little bit buggy. It's not version 1.0 yet. Sometimes it's just like you put the component back in and it works. And that's a bug that's like beyond us. That's a bug in like Grasshopper itself, okay? But you need to verify that that's actually the problem. Sometimes the components, like when they connect, especially if you connect them backwards, like don't always work right. Okay, and a thing that I talked about in lab too that's really helpful is so in a variation of this pattern that I talked about working on one piece and figuring it out before you add something else. If you have something that's just like not working, like you don't know why it's not working. Like I had this problem with a project I was looking at where like we were just trying to draw an arc and it like wasn't working. Okay, so let's start a new file or a new script, right? And let's just draw an arc. Okay, let's just like strip out all the other stuff we're trying to do and make sure that we understand how to do the basic part of it, right? And if that works, if there's no bug with it and you understand the concept of it, then you can begin to plug that like back into this program. And I think especially when you're starting off, some of the fundamental stuff you may have forgotten, or you may have gotten jumbled up with some of the new stuff that we talked about. And so actually, like, not starting the whole thing over, but just isolating like part of it can be really useful, okay? Just so that you make sure that you understand it. Don't, again, I really suggest starting a new script. Don't like turn preview off on all your other stuff and then move over to a little pod and make your little script. Like, get rid of all that other stuff. Like, just take it all out of the equation. Just have a blank sheet of paper, okay? I think it's very useful, and it's possible that something in the other piece might affect it, even if you've turned off preview. You don't want to deal with that. You just want to make it as clean as possible. And I'm going to go back to the second point also. Sometimes it helps if you have a script that you've kind of figured out, but then you end up with a bug. Start over. And sometimes this is like the worst advice that you can give a student, especially a frustrated student. Because nobody wants to hear that. Nobody wants to hear you just need to start over. Like, what if your professor told you about your design like at this point in the semester, right? You've been working on it for 6 weeks. You just need to start over, right? But in programming, especially like when we've done these scripts and they're not very like complex, if you start over, right, you kind of have an idea now of what the design is like supposed to be, right? You've just done it, but maybe you just connected something wrong, you got distracted, or like whatever. If you start over, you don't have any of those assumptions anymore because you have to think about like what goes where and what goes next. And sometimes that does it. Sometimes you just made like one little disconnection in that, but rebuilding it with a plan, you got it. Like you take care of it right away. Okay? So that can be a strategy. Okay? If you've isolated it and then also it's a way to get it cleaner too. You'll find out sometimes that you made it really inefficiently, and it's really hard to find all the connections you need to make. By starting over, you can make those connections right away. You can make those different like proportions right away, instead of having to like reverse engineer the whole thing. Okay, so it's not like the highest thing I can recommend, but it is a strategy that you might think about. Okay. I've talked about this a lot, but in visualizing things. I can't say it enough though. One of the hardest parts about programming is that you can't see what's actually going on. Grasshopper is nice because you can see the output and you get like feedback, right? You play with the slider, the thing does something, right? But the numbers that are inside the program are so critical. They're the important part, right? And you can't see the numbers most of the time, okay? You can't see the data. This will be huge in the second half of the course when we actually get into like manipulating the data structures. You'll see how important it is, and you'll see how important it is to visualize what's happening inside the program. Okay, like you've got your computer in front of you, right? You're working on a computer. Like computers work on the principle of like hiding as much as what's going on inside the computer as possible. Okay, like they're always manipulating data. They're putting things in databases, pulling them out. That's how your email works. That's how your CAD program works. Like that's the principle of like computing, right? Abstraction. But again, when your program crashes, it has a bug. You can't see why it did that. Your laptop turns black and nothing works. Like it's because that layer that's underneath it, something happened there, right? That's how it's supposed to work. What we need to do is get inside of it though when we're in Grasshopper and really understand that. Okay. Always check the inputs to see if you have the right ones. You can plug things in, and sometimes actually you won't even get an error, but you've inadvertently like plugged in something. Let's say you did a series and you expect a list of numbers, but you didn't tell it like how many numbers to make, and you just said 0, so it didn't make any numbers. So even though you think it's a bunch of numbers and you plugged it into the inputs, there's no input, like because that component's not making any numbers. Okay, so you gotta check. That's one of the easiest things to do is make sure that you're giving it the right input. Does it expect a curve? Does it expect a plane? Does it expect a list of numbers? Okay. A lot of this is the stuff that you guys are learning now, like once you figure out what a component is. But even I forget sometimes, or I plug something into the wrong thing. So you need to check that. This is a big one. We'll talk about this just in a minute here. But not only do you have to have the right type of data, but you have to have the right number of things, right? We talked about data matching, and if you plug things in and something's expecting 10 numbers and you only give it 5, you're going to get a non-result. Or if something's expecting, like in a loft, you need more than one curve for it to work, right? If you don't plug in more than one thing, it's not going to work. And also with lofts, if you have a list of curves and a list of curves and you try to loft them together so that you get individual lofts, it's not going to work because they're not structured correctly. What it's going to do is it's going to make a loft out of like both lists of curves, like a big piece of taffy, because it's not structured properly. Okay, I'll show you an example of that in a second here, because that's a pretty common bug that's come up. Okay, so data structure, even though we haven't talked a lot about it, this thing with graphs and flatten is really important. Okay, something that's really useful when you're working through a problem is to actually talk to somebody about it. And I'm sure you guys just sit around all day talking about your scripts with each other. It's become your favorite pastime. But just trying to explain to someone in the class or someone who knows the software like what you're trying to do and expressing your frustration with it sometimes actually helps you solve the problem. Like when you get out of the computer and you try to articulate like what you're doing, you'll suddenly realize like, oh yeah, like I just forgot this piece of it, or oh, that's what I was supposed to do. I heard a story about this software company used to have like a teddy bear. And they would say that like if you have a problem, you go talk to the teddy bear, you explain it to it, and that's how they would solve a lot of their problems. They would just kind of express their frustrations to it, and they can try to explain it, and then suddenly the light bulb would go on. This is part of why we work in teams, because when you guys are trying to write these scripts together, you're saying like, well, I'm trying to do this, and your partner's like, well, why are you doing that? Like he told us to do it this way, right? You're gonna get that feedback and get yourself outside of the computer, and that's a good way to actually find your way through the problem. Okay. So if you get really stuck, try talking to somebody about it, and sometimes that'll get you unstuck. Okay. When you're doing this is kind of a variation of slow down. When you're working on your programs and you're trying to find an error, again, I think about this in terms of like appliance repair, like cars. You want to be systematic. Like when your car's got a problem, you don't just go like ripping things out and plugging things like back in and like pouring in various fluids into your car. All right. But that's how some of you guys debug your like Grasshopper scripts, all right? Just as it won't work for your car, it ain't gonna work for your programs, all right? You need to have like some like order. It's like, okay, like I'm gonna try like this thing, and I'm gonna try plugging something into it, and I'm only gonna deal with this one component, and until I'm sure that that's not the problem, and then I'm gonna move on to like this piece, right? And like don't do something if you really don't know like why you're doing it. Okay, if that happens, maybe talk to somebody, like ask me, talk to Yashka. But I really don't want you guys, because the thing is that it goes back to that slide. It's like my code works, but I don't know why. That's not good. Because then what happens if you get a bug later on, or what happens when you try to design something yourself again? You didn't learn anything. I mean, you got it to work, but if you don't know why, like game over. It doesn't really matter. Okay, so. Be systematic in your approach. Like check things off. Like I tried this, I tried that. This is the most likely place where the problem is. This is the next most likely place. All right. When you're doing that too, particularly if you're going to just plug things in or whatever, save a copy of it. Like have too many of you guys don't have enough copies of these. Like when I'm working with you in class, you have like the copy you started with and then the final copy, and there's no, you can save multiple versions of it as you go. That way if you break something, you can go back to the place where like, okay, it worked at this point. Like when I was working on it an hour ago, or well, more like 5 minutes ago, right? It worked, okay? You can't do that with your car. You don't have multiple copies of your car, but you can do it with your programs. It's cheap and it's easy, and then if you have a crash or whatever, you didn't lose your only copy. I'm really surprised because I would think that with you guys modeling in CAD and in 3D and stuff, you guys would get in the habit of making multiple backups of things, okay? You gotta set auto backup. You gotta like save like crazy. I always save as. I don't save over. I just save a new copy. Data's cheap. Have like 20 copies of your script. Have like 40 copies of it, They're time-stamped. That way, if you do something, you can go back to the last time it worked, okay? This is kind of going to be contradictory, but I'm going to say it anyway. With programming, remember I said, it's really, a lot of it's internalized, it's not visual. Because of that, when you're programming, you have to almost keep a copy of the program like in your head of like what's actually happening in the program. And that can be very difficult, and it takes a bit of sustained focus, okay? And so it's actually beneficial, especially if you're not particularly skilled at it yet, to schedule an amount of time where you can work on it so that you are in the program. Like, you've started it, you've messed with it, you kind of understand like what's going on with it. You're like Neo in the Matrix. Like you can kind of see the code, that you're inside of, okay? I know that's hard to do, and it's hard to schedule your time that way, and it kind of contradicts a lot of advice that you'll get about time management, but I do think that I would work early, and I would work in a sustained like amount. I think that's a very successful way to start programming, because holding all this stuff in your head is really hard, okay? But it's really vital. And it's hard to come back to a program because then you have to load all that stuff like back in your head again to know like where you left off. That being said, and I'm going to contradict myself, if you are really stuck on something and you're having trouble debugging it, you've talked to a teddy bear and it's really not helping, okay? The best advice I can give you is just to like walk away from it for a while. And I mean like seriously, like go get a burrito, go take a shower, like go take a walk, like do something like else, and you'd be amazed. Sometimes it just comes to you. It's just standing in the shower, you're just like, oh yeah, like that's all it is. It's an easy problem. Okay, you got to get out, like, and your brain's doing work. The program is in your head, like you've like loaded in your memory, right? But you focused on it so much, you've tried so many things that you can't make that like intuitive leap. Okay, so you just walk away from it, and your brain's working on the problem the whole time. Okay, and it's gonna find the solution. This is a great tactic for like design. I learned this from advertisers. Like just get away from the problem. Okay. It works for me, like, frequently, okay? So anyway, that's pretty useful. If you learn from bugs, you'll spend less time fixing them later, right? So you'll inevitably, I think we probably all have the same bugs, but I think it's our capacity to kind of recognize a bug as a pattern and then not repeat it later, or immediately recognize, like, when you see it, oh, that's the problem, right? That you really reduce that amount of time you spend making and fixing bugs to a lower number, all right? Like, you might make the call bug that I've shown you a bunch of times, but then you'll immediately be like, oh yeah, I just need to, like, graph that, right? I've seen you guys do it. I mean, it happens. So if you can kind of understand these as patterns and learn from them, it's going to help you quite a bit, okay? So we'll talk about some of these right now. So some of the bugs that come up have to do with the inputs that you have, right? Getting the right inputs or having them in the right number. Basically the patterns that you choose. Some of you guys, I've shown you patterns of things, right? Like how to divide a surface, or how to make or how to make like a grid of something, right? And instead of thinking about the problem, like, you'll go to the pattern. You'll just be like, oh, if I need to make that, well, there's this pattern that Nick showed me, and you choose the wrong pattern. Okay, so a bug happens right away because the wrong pattern gets, like, chosen. All right. So understanding not only, like, how to get the effect, but, like, why is really important. And then the ordering of components. I still see some of you guys doing things like plugging in a move and then plugging in like a rectangle after it. Okay, the object comes first, then you move it. Okay, so like ordering of components is kind of a bug as well that we need to look at. And then lastly, data matching, and that's like line weights. That's basically like a perennial problem in Grasshopper. But we'll talk about that also. All right. So I'm going to show a couple of examples of some of these, just so you guys get a sense of. I've been like throwing out a lot of abstract ideas. We need to actually see some of this stuff now. So, like some of the things I've been talking about, like I'll just give an example here. We have the old center box. You have to think about the order in which you're going to move. You're going to like distribute these, and we saw one way of doing this, which is to do points and use points to define where our boxes like show up. Okay. And I think that I've seen some confusion with this procedure, right, which comes before the box. Like you make the points, you may have numbers, numbers make points, points tell you where the boxes are, right? With a pattern that's like this, where you have a box that you already had, and you move it. So we're going to move in the X. And in fact, I could do a series like this. And it's an understandable bug because they're both, the output seems very similar, right? You want to move like a system of boxes, like you do that. But some of you guys have sort of like conflated it where you put the move like on this side, and I see things like that. All right, which look, it actually doesn't it doesn't throw an error, right? That doesn't turn red, so you're like, oh, what happened, right? But what actually happened is that it expects there to be some kind of like geometry, but you haven't given it any geometry. And in fact, plugging this in where it looks for a plane doesn't do anything. Okay. So again, you may have internalized the pattern, but you've got the order like flipped, or you've confused one for the other. Okay, those kinds of things happen. Now I think we talked about this before, but it's not just kind of a gotcha. There's really a difference. There's actually a difference in these. What's the difference between having a box and like moving it? Like what do you get with that? Like what's the advantage of that technique? If I make a box and then I move it. Good. Changing the state of the box, which means what? If I do something to the box, what happens? It affects everything that comes after it. All right. So yeah, if I go in and I set the number and I just alter these, that's a bad one to change. Let's change another one. Changes into Z. If I go through and I change this, right? So there's a reason why I would do that. Like I would make the object first, or I'd modify it, and then I would like transform it. Then I would move it. Okay.
But if you had it the other way, you change the Z, it would do the same thing. Wouldn't it?
If I change these.
If you had the suit, you had that order.
Yeah, this one works, but here I can change the object. So I'm actually starting with like the position of it first, and if I wanted to replace that with like a cylinder, then so I've changed that piece of it. I mean, it depends on what part of the script it's in. It depends on where the data is like actually coming from. Yeah, actually Clark's right. So what I'm doing is I'm actually making these, and this is actually dynamic. Yeah. But the important thing is, right, is that we've seen is that the one pattern like doesn't work if it comes before, and the one pattern works if it comes after. Okay. So there's always a reason for why you want to select these. Another now that I'm actually on this one, this is actually a good place to show something else. My keyboard here. There we go. Okay. So we have a series of these boxes, right? And if I plug in a number for them, actually I just do a number slider. That would be even cooler. Okay. If I plug in a number slider, right? Just make this bigger here. If I plug in a number slider for this, I'm putting in one number into 10 objects. So you get the same output for each one. Okay? If I plug in a series component, if I can connect here, I get a different, I have 10 inputs and 10 inputs, and so each one gets a different like number. Okay? One of the errors that comes up, particularly if you don't consolidate your sliders, you don't create like dependencies. I know some of you guys make sliders for lots of things, and so that everything can be controlled, but they're not like talking to each other. You can wind up with this kind of a bug. Well, and also you got to make sure that you have to also watch the way that you do like your program constraints. If you have 0 for that series, right, then you don't get anything. That's what's happening here, right? It's only until I get another number in there, like I get a number higher than well, one that's higher than 0, that I get a result. So you want to limit that for yourself. I know you guys have seen this before, but these are bugs I still see. Okay, so what happens here is I've got 10 boxes, but only 4 values that I put in, right? And so what happens is that the first, second, and third, and fourth value change, and then it just keeps repeating the last values, all right? And this is just a basic example, but this happens a lot when your things don't match up, okay? It's only as you go that you actually get. Now that might be a result you can exploit in a design, but I'm just telling you that if you have the data amounts mismatched, they aren't gonna work. That's something I've seen come up. The remedy for that is to make sure that you're going to constrain the inputs and the variation, right? So that now whenever I have 6 of something, I always have, and then that's never going to cause a problem, no matter which way I change that. Okay. And I think you guys have seen it before, but a lot of this is like review. Okay. Another bug that is really common that we've seen, it bears some repeating, is to do something like, oops, kill that one. is one we've seen, and this is actually causing a little bug right there too. So this is 2 bugs. One, the C's don't match, right? So I'm getting that repeating in that. And this is a cause of another bug, right? Which is this idea that when we have these grids that we're trying to take a row of something and make it work in 2 axes. We want to graph something, all right? I think you guys have seen this in some of your projects, like when you've created your module that you're distributing and you want to copy it in a column and then a series of columns, or you want to copy it in a row and then you want to copy it up, you end up with this kind of like stair-stepper effect. It's because they're not in like a data group. Another way to group stuff that we've talked about, or I've shown you, I guess, is to actually put it inside of a group. And that sort of creates a similar structure. They're not the same as a graph, but then you could do something with that group, like take the series and move it. And that would also get you a grid, okay? So this is kind of a combination of the two. With points, there's really no reason to do this because I could just go ahead and make it with the point data. But you know, again, what if you had some object that you reference that you made, right? This kind of structure would work. Like you make them on a series, and then you want to copy them up as a row. You could use a group object, okay?
So in that case, you want to bring this number slider, make it the same number slider for both C's, right? The series.
No, it doesn't matter because the group is like is now one unit. So all I'm doing is like making copies of that one unit. Okay. It's not a graph though. Again, I want to stress that. In fact, some stuff gets really weird. You can put stuff into a group that's been grafted, and then you end up with multiple grafted objects in it. You need to flatten it before you group it, and that'll make the structure. It'll make it like something that you can copy. Okay. You can also, guys, I think I've talked about this, but there's actually a flattened component. If I can spell flatten correctly, there's a flattened component, and there's a graph component, and it says tree. They're still talking about flattening graph. If you pipe something into it, it actually pipes out a grafted version. So if right-clicking and setting it is making it hard to visualize like what's grafted and what's not, you can actually explicitly use these components to do that for yourself. All right, so those are also kind of useful. Speaking of graphed and flattened, I think an example of this that might help us is one that's cropped up with one of the projects. And I know a lot of the group members for this are here, and I apologize for the redundancy, but I think this is a teaching moment here. So if you guys remember that project that's like a basket, it's that wooden building that has the slats that are kind of going like diagonally around there. A couple of the groups ended up with an issue with that when they were trying to loft those. And it's a really good example of like matching data structures to each other. Okay, so I want to show you an example of that. And also, it'll give you a sense of how they did their projects, which could also be cool. I like this building actually. Okay, so there's two rows in this building, and what we want to do is we want to put these slats that go between it. Okay, and so what we've done is put in these horizontal frames, and this is another bug actually that's just Grasshopper is not very well designed from an interface standpoint. Some of the names actually change depending on like like it says graph tree instead of graphed. It gets kind of confusing. Here's another one. This gives you one horizontal frame, and this gives you horizontal frames. And so it's really easy when you're doing a search for it to get the two confused. So just gotta be really careful with this program. It really needs like a redesign from an interface standpoint. Okay, editorial over. I'm sure I'll get a call from the Grasshopper people when they watch this on YouTube. How dare you insult my program? I just connected it there. Okay, so the horizontal frames, and we use frames because the frames are going to turn with the flow of this, which is really nice. And that's gonna give us the right angle for these. So we do the frames, and we're gonna have the same number of frames in both. And I'm gonna take this copy that I moved and I'm gonna rotate it because there's a twist to it, okay? And that's gonna give us that angle. And see, I'm already confusing myself here by there. Okay, gotta keep this organized. And I'm just going to plug in a radians. And for time, I'm going to just set it to be 15 dBs. There, now it all works. So I've twisted it a little bit. And I've got one copy of it that with the planes, and then one copy of these that's been rotated. I think I actually plugged in the wrong one. Let's plug in this one. Okay, so the bottom one and the top one that's been twisted slightly. And I'll show you, this'll make it, okay. So what I've done, actually I'll do some, no, okay. What I'm gonna do is put some rectangles on these frames. Takes a little bit to set up. And this rectangle pattern is one too. I've seen some people stop using this, and they're using the polygons and things. This is one of the better ways to draw squares and rectangles. And I know it takes a little bit of work, but you don't want to forget this pattern. Okay, so just to refresh your memory, the rectangle pattern uses like a domain, because it's a range from 0.7 to -7, right, in this case. Okay, now I've got my object, and I'm going to distribute rectangles with those frames. So this is almost like the first example. And now you can see this here. Make a copy of these rectangles here. And you can see that they're slightly like off angle from each other. Now, so this actually illustrates a lot of things here, such as organizing your script. All right. I had one state of this thing, which I then moved and rotated to make a new state. I copied the same horizontal frames because I want them to use the same, I want them to be constrained. I want the same number of frames in both of them, right? Because otherwise they're not going to talk to each other. They're not going to have the same amount of data. So you wouldn't do two sliders for this because that would be an easy way to break it. You want them to share the same slider, okay? Then I made sure to plug in the original curve here and the other state of the curve here. And then I made this rectangle object parametrically. I tested it first, I zoomed into it and I looked to make sure, okay, is that thing making a rectangle? Like, did I mess that component up? Then I distributed it. Then I made a copy of this one so that it can maintain the same controls, because again, I don't want those two sections to be different from each other, right? So they share that. It's still pretty efficient. And I kind of put these on the same kind of column with each other so that I understand where those two, so there's like the bottom curve and the top curve, okay? Even the way that I organize this makes sense like spatially, okay? Now I've got these together, and okay, so now we're gonna do the anticlimactic gesture. You would think, okay, I'm just gonna loft these things together. I'm gonna loft the bottom to the top. And that's gonna work, right? Because the idea is that that's gonna talk to that, that's gonna talk to that, you know? Just like if you took two sets of points and you just plugged them into a line, that would work. But loft doesn't work that way. A line has two inputs. It has an A and a B input. So that makes sense that those two would match up. But loft, if you remember, you have to plug something in, make sure I got these right, bottom ones, and then you hold shift and you plug in the other ones, right? And so look at this crazy spaghetti. That's actually kind of cool. It's like a Matchbox track. But if you follow our debugging, first of all, okay, the loft is the cause of the problem, right? Like we are doing something incorrect with the loft. That's the last thing that I added. I'm gonna put a panel in there. What the heck is going on with this thing, right? And what I end up finding out is that I've just got this long list of rectangles. And that's what's happening is instead of the two talking to each other, saying like, okay, bottom A and top A connect, bottom B and top B, I want you guys to connect. There's just a big long list, and what it's doing is it's doing what it's supposed to do. is just saying, okay, you gave me a list. I'm going to just connect them all together in that order. So I get a big, long, like, Twizzler. All right? And that's the thing about debugging, guys, or the thing about computers in general, is that they only do what you tell them to do. Like, they're not trying to thwart you. They don't have like malevolent intelligence. They only just follow instructions. Okay? If you misinterpret the instructions, or if someone, if the instructions might be wrong, you're going to get the right result. You're going to get the result that's intended, and that's how this thing is set up right now. It says, okay, you gave me 2 lists of points. I'm going to make your Twizzler. Okay? What you want to do with this kind of thing is graph the 2 structures together. So I'm going to throw in a graph component, and my inputs are the rectangles, and my outputs. So now they're in these little baskets, and each one has just one object in it. Okay? And then I'm going to make another copy, and I'm going to graph, and the structure is going to be exactly the same. Okay? So they're in these little, like, stupid little cells that each have just one thing. But it's different from a list. Okay? Because when I plug these in together, you can see it's broken now, because the thing is that I even though I gave it all these structures, each one of those only has one curve, and a loft won't work with only one curve. It needs 2, right, to go to stretch it together. If I plug in this other set of baskets here, you're going to get the result that you want, because the 2 structures like match up with each other. Okay? And if you look at that final structure, that ends up being, these are my loft curves. But if I look at this structure, now they're N2, right? Before they each had 1 in each little unit, N1. There's still 104 values, I guess, but now they're contained in these little kind of unit clusters of 2. Okay? This doesn't just work with like 2 things. If I had like multiple levels of this that I wanted to span up, I would have to graph 5 of these things or 6 of these things or something like that in order to match that structure. But that's why this doesn't work. That's why when we were doing sweeps with this, it works with sweep the same way. The rails and the sections have to be grafted as well in order for the structures to match up. Because otherwise, what's that?
It'll go one way. It's all meaning.
Why does it all go one way?
Well, isn't that, how do you get it to go to the left?
We can make that happen. Totally. So it's just about this is about the rotation in this script. So I'm gonna make a 360-degree slider and plug it in for the radians. And what we're doing is essentially just moving, we're rotating 1 row. And so if you want it to go the other way, you just go negative. Good question, though. I'm sorry, I kind of glossed over that. But the way that this script works is just by rotating that row, and then when you connect them together, it's like having strings, and they just kind of twist. But that's how these groups could make this project work. Okay. But it's, you did what you expect to do, which is just plug one thing into another and they should match up. But in this particular case, because of the way that loft works, they're not going to synchronize. You need to structure the data the same way. Okay. You could try this experimentally, right, by just try plugging in the same amounts, and then you get an error, and then try graphing it and you get a different result. Like, you can kind of systematically go through it. But I think it helps to understand the principle of why this kind of thing doesn't quite work. All right. You guys are getting bored of debugging. So let's go ahead and talk about diagramming here. One thing I want to quickly show you is for these 3-dimensional objects, I do like this particular style of drawing, which is to make a silhouette around the object to separate it from the ground, and also if you have gaps in something, like for instance our brick walls, it'll tell you on a white field whether there's a hole in something or whether it's a line on the object, like whether it's part of the geometry. Okay? This isn't just like because I like it, it's actually really functional. I'm going to show you how to do this in Illustrator really quickly. I bet you didn't think you would get that today. Well, Illustrator, okay. And I'll tell you guys too, again, there'll be a link online to some Illustrator tutorials if you think you need some remedial Illustrator. So what I got, I gotta break this thing down here. Yeah, okay. We go ahead and start with this. Whoa! If you copy paste something that was in your buffer from Grasshopper, you get XML. All right. So my make 2D starts off like this, okay? And to make, this, you don't go through and trace like the edges of it, especially if you have like rounded things. It's going to drive you insane. Like it's too much work. I'm going to show you a fast way to get a silhouette of something. All right. So you pick everything, and you're going to use the live paint tool, which I always have trouble finding. Yeah, live paint bucket. All right. And I'm going to set this up for black. And when you click, so you select everything and you click onto the group. And live paint works like sort of like a coloring book. This is another way that you can use to shade objects. If you haven't like done this before, I could use different shades of gray, and I could sort of fill in the different parts of my object in order to make it more three-dimensional. In this case, I'm just using it to block out the geometry so that I have it, so that I can make it a solid essentially. Okay. So if I go in, I can take this object, and I've got it as a group. This is a little bug, but I'll show you how to fix that. So I fill in as much of it as possible. I fill in the object. I leave out any gaps that are in the object. I don't want to fill those in because those are the holes. Okay. This is my silhouette. Then I expand it because that gets me out of the live paint. I got to ungroup it because live paint like stacks the fills with the curves. Ungroup it. So I've got my fills and my lines like separate, which is great. I go into this group, and I'm going to go to Pathfinder, and I'm going to just do a shape mode, and I'm just going to basically, like do like a unify. That just unifies all those edges. I still have this little one left over. I can just go ahead and erase that, and it'll fill in. If that was a hole, I would leave it, but it's not. And I've got the outline, so I've got my shadow. Now what you do with that is just flip it, and that gives you the silhouette. Then I drag that, I turn on my lines, I put that on a layer above my lines, and I give it a thicker stroke, and that's a quick silhouette of that. And that works with complex objects and curves and all kinds of things. And again, it's way faster than taking the pen and like tracing all that stuff. All right. If you find a better method, let me know. I think this is pretty good. I don't know like everything about Illustrator, but this is a thing that I use pretty frequently. That's just a quick thing. All right. I think when you're dealing with things three-dimensionally, I think you want to be able to set them off from the ground. I think you guys should experiment with tone on these. I know tone has been verboten in second year, and I think in digital fundamentals we didn't do a lot of it. I'm going to show you some examples of some three-dimensional toning. All right, believe it or not. Okay, so I've shown you this example. I've put this in the PowerPoint so that you have it handy. This is the MBBJ. This is a form of diagramming that I really like because it relies on line weight. I've talked to you about this before. Okay, so line weight, line type, hierarchy, very, very important. Okay, so we've done that. This is another one that I showed you guys, the other example from a Grasshopper project. I like this one because it tells a story about how this thing works, and it doesn't do it necessarily in a linear order. It actually takes you through an overview of it first and says, this is kind of the general idea of how this form emerges. Then it gets very specific about how the cross-sections like work, and it diagrams it. Lindsay? This one? They changed the background in Rhino to white. The actual viewport background. It's in the settings, and they just did a screen capture. This is the Rhino viewport with the ghosted. Good question. Yeah, do you guys understand that? They just did a screen capture in Windows with a white background in Rhino. Rhino's usually gray. Turn off the grid, make it white. You can cap this. I think this is like cleaner because I like the line art style, but sometimes this tells the story too, Yeah, good question. So then we have this, and it's color coded, and it has the parameters in it. I kind of like these. You see the variations in it, so you understand what's possible in the program. It's a nice layout. Then they go back and they talk about how it's controlled by this other kind of curve. So you've got this relationship in the section and this relationship in the rail. And then you can, and then they go back and they show the cross sections, and then they show the form of it. So this sequencing is pretty good. You don't have to render it like this, but it just gives you an idea of the possibilities in the system and a sense of how it works, right? I may not know specifically how they did it in the script, but I could reverse engineer it from this, and that's kind of a goal. Is like how could I make this, all right? Chris Bjorkrum's book that just came out, Digital Strategies and Material Strategies and Digital Fabrication. He actually, so these process things are really important. I can't overemphasize it. It's so important that Chris got paid to write a book of these things where he goes through a bunch of projects and essentially diagrams like how they were fabricated, like digitally. So all this stuff that I'm showing you, like there's actually a book of it. It's really valuable. There needed to be a book of it because no one actually talks about their stuff this way. There's a huge knowledge gap in fabrication, in computation, because it's incomprehensible to people, all right? So you cannot have this PDF, but you can buy a copy of his book. Anyway, but I just want to show you guys, this piece upstairs, like it goes through the process. This is exactly what I showed you guys, or you'll see in the video, okay? Not rendered, but there's the Gramation Kohler robot and a description of how the robot like lays the brick. Okay, so not only is it like because I say so, but because there really is a there's really like a commercial reason for it, and there's a pedagogical academic reason for it. Like we need to get this stuff out of the computer and into our reviews and into publication. Okay. Other types of diagramming. So some of these strategies may apply to you, they may not, but I'm always interested in sort of explaining formal processes, right? So like there's an order of operations here that describes how this form was resolved. So you might talk about your project in this manner as opposed to like digging into the really raw computational stuff. Maybe it's about a series of gestures that you create. Yours might not be like this, but I want to point that out. Note the use of line weight, the use of tone, the use of line type to suggest step to step. There's another set of formal factors. In your studio work, I wouldn't like this as so much for me, but I think in your studio work, I think it would be useful to take different states of your project, right, and show how you apply the different like manipulations to arrive at an end result. Okay? You could do this with the stuff you know. Here's another example of it as well. Gosh, this stuff looks terrible on the big screen. Okay. Another example. And you'll see these in the handout. And another example. So there's a series of like, you start with a program and you wrap it in something and you cut holes in it and you pinch it, and these kinds of gestures, right, they tell a story. Like there's a reason, there's a rationale for them, there's an ordering to them. These ideas of Grasshopper, diagramming can be really useful in this context. Okay. For me, though, I am interested in this kind of idea of how you did it geometrically. I'm not interested in like the sort of like poetic description of it. I'm not interested in the sort of like phenomenology. I'm just giving you examples of these as stuff that you could talk about in studio that Grasshopper would facilitate. I want these. Okay. I want these from you guys. Okay. If you can, these are like stylistic. They're very descriptive from a design standpoint. So I just want to put those out there. Okay. All right. So that's what I have to say about debugging and diagramming for today. Do keep up with your project. Edit those scripts, make them more efficient, and work on your